Is my slide is visible to you?
Yes, ma'am.
Thank you, Priya. Right. So today's session is about finding fixed points of functions. Finding fixed points of functions. See, with respect to this particular subject, always we are taking, we are going to write a program or functions with respect to some mathematics, right? We will take a mathematics concept and we are going to write a program to solve that, right? So one of the very famous problem is finding the fixed points of solutions or functions, I can say. Okay, so let me understand what is meant by finding fixed points of functions. Okay, so let us take a number x. Okay, this x is to be called as a fixed point of a function if x satisfies the equation f of x equal to x. So which one we are calling as a fixed point? X is to be called as a fixed point, right? So f of x is nothing but x, then we say that x is the fixed point of the function f. So how? This is a constraint. Okay. So now in order to find x, for what values of x the function, okay, is going to give x. That is our problem. Okay. So for some functions f, we can locate a fixed point by beginning with a guess value, right? We will start with the initial guess and then apply the function f and guess and get another guess value and then apply the function f to the another guess value, and this procedure has to be repeated till we are getting this condition, right? F of x equal to x. So if you look at the definition, x is the initial guess and apply the function, you will get a value, right? That value is not x, it may be something else. Then you go for the next iteration. So something else you are getting, right? Consider it as x1. You apply f to the x1, okay? It is not equal to x1. Then once again you apply the function and so on. Okay, so it is the iteration, and sometimes we have to break through, right? We have to break the loop. So when you will break the loop, okay, what you are going to get that x, consider it as xn, and what is the previous value. So if it is approximately closer, okay, equal, approximately equal, then we can stop. Okay, so always this kind of problem we have already seen for some other mathematical functions, solving some other mathematical functions. Okay, so now this is an iterative process. Given the guess value, apply f, and if the condition is not satisfied, and once again you apply, and if it is not satisfied, again you apply, and it will be continued. Okay, n times. So you will have a base condition, you will have a terminating condition, right? The base is initial guess. The initial guess should be very properly, you have to choose. Otherwise, the number of iteration will be very longer. Okay. So if I say why this problem is called as a fixed point, why this is called as a fixed point, what is happening here, right? Iterating the function f, okay, we are iterating the function. What is the meaning? Actually something is feeding in, okay, for example the guess value, and apply the f to the guess value, get the output f of x. That f of x is that output is given back as the input to the same function, right? So finally we are getting a fixed value, that is a x. Okay, so if I write in mathematical terms, x naught, consider x naught as a guess value, f of x naught is x1. Then what you will do, f of x1, find x2, and take x2 as an input, apply it, right? So if you look at indirectly inside, what is happening is f is applied multiple times. Okay, so here I can say it is f square of x naught, and here I can say f cube of x naught. it will be repeated n times. So finally, fn of x naught. At that point, okay, that f of x equal to x will be satisfied approximately. Okay, right. So now, let me ask you to solve this particular question. Given the equation, find out the fixed points. Students, given this equation, find the fixed point. First equation, f of x is nothing but x squared minus 3x plus 4. Is there any fixed point available or not? What you will do? You will take a guess. Consider it is 0. F of 0 is 0 square minus 0 plus 4. So what is x? 0. But once, what is the answer? It is 4. So it is not. So what you will do? Go for the next iteration, right? So you are getting 4. So f of 4. So 4 square minus 3 into 4 plus 4. You will get something, right? Can you find out a fixed point for this? Any answer?
It's not a fixed point, ma'am. We have to move for another point since 0 is not the same as 4.
Okay, so Priya says that there is no fixed point for this equation. Whatever you are applying, we will not get the x, right? So that's what she is saying. And let's go for the next problem. F of x equal to x cube. F of x equal to x cube. Can you find out fixed points?
0,
so for any
ma'am.
function, you can have
1.
more than one fixed points. You can have, for example, 0. You substitute 0, 0, 0 cube, 0. Okay. You take 1. 0 is a fixed point in this case. If you take 1, 1 cube. So x is 1, x cube is also 1. So 1 is another fixed point. Like that, can you find out one more?
1, ma'am.
1, I already told. 0 is a fixed
0.
point. 1 is a
0
fixed
and
point.
1.
Yeah, 0 and 1. You take minus 1. Minus 1 equal to minus 1 cube equal to minus 1. Right? So 0, 1, minus 1. 3 fixed points are there. Okay? Right. So now let us take this. X square plus x plus 1. Can you find any fixed point for this? We can't find, right? 0. If you supply 0, you are getting 1. If you supply 1, 1, 1. So 3, you are getting minus 1. 1 minus 1. Again, 1 is a. So this is the problem. It don't have fixed point, right? Okay, you take this x by 2 plus 1 by x. You take this equation. F of x is equal to x plus 1. So by seeing this equation only, you can conclude what is that. If you give x, always it is giving you plus 1. If x is 0, 1, x is 1, it is giving 2. So never converging, right? So there is no fixed point. Okay. So, so this is the way we can able to find out the fixed points. Okay, let us take one example. This function x by 2 plus 1 by x. So what you will do? So have a guess of x equal to 1. So 1 by 2 plus 1 and see 1 if you are applying 1 by 2 plus 1 by 1 1. So you will get 3 by 2. That's what it is written here. So x2, what is that? x2, 3 by 4 plus 2 by 3. So you will subsequently you will substitute the output of the previous one as an input, and you will get a new value, and finally you will arrive to some converged value. Okay, approximate value you will get it, right? Okay, so now let us write a program for this. We understood thoroughly what is the logic for finding the fixed point. So let us write a program. So if you look at this program, so I'm going to define a variable tolerance 0.0001 to this much precision. Okay, so let us come to the main logic. fixed point is my algorithm, and for which there are two arguments, function and first guess. Yeah, you must know what is the function and what is the initial value, initial guess value. So there are two arguments here. And then what I will do, first of all, what I will do, actually here, if you look at, always we go for whether two values are close enough or not. So I have a, I would like to use close enough in my program. So I'm defining it first initially. Why? Because I will call here. So close enough, given two values, and I will find the difference and then get a approximation, that is absolute, sorry, not approximation, get a absolute value. That value is less than the tolerance, then it will return you true or false. Okay, so now define try guess. So what is the function name here? Function name is I think it is a try, yeah, guess value. Okay, so what you're doing first, let next is f of guess. Yeah, so what you have to do, given the function and given this value, you have to apply the guess value to the f, right, and equate to next. Then what you have to do, you have to find the next and guesses closely, there is no gap or not, is there any gap or not, so very it is very close or not, right? So guess and next whether it is close or not. If it is close, then next is the answer. Otherwise you have to call the function once again with the current name, current value. The current value is next, you are passing it over here. So the next what you are getting will be used as a guess for the next iteration. Yeah, so this is the program, and I hope that so many programs you have written, so this will not be a difficult one to write. Okay, so defining a fixed point, and inside we have two functions, define close enough and define try. Close enough will check for the closeness, and another define try is we are trying to find out the fixed point. So what we are doing is apply the guess to the function and obtain next. Okay, and then next and guess are close enough or not. If it is close enough, and the next will be the answer. Otherwise, you have to call the same function by passing next as a guess. I hope you understood. This is the way we can write a program for finding the fixed points of functions. I think it is easy to understand. So you will be calling the function. Yeah, this is inside the fixed point you are calling it, right? So now let us start by calling the function by passing f and guess. Okay, fixed point is my algorithm, and f is cos, and guess is 1. So if you call the function with guess, sorry, with cos and guess value of 1, what happens? Okay, f is cos, and the first guess is what? It is 1, right? With the initial value of 1. So what happens is wherever f is there, the cos is substituted. Cos of x, cos of 1, you will compute and assign to next. Okay, so you will check the guess and next is close enough, then you will pass that value cos of 1 as a guess value, right? Okay, so now define the function. We know how to call it. We are calling it by a built-in function cos, right? You will get an answer like this. So let us find out a solution, fixed points for sin y plus cos y. How to call this one? So in the earlier case, fixed point is my algorithm and function name, and cos I am passing. So now I would like to find a fixed point for the function sin y plus cos y. How will you call? What will be your initial guess? From which value you will start? Students, how will you call the function? Fixed point and then See, there are this is a arithmetic expression, right? Sin y plus cos y. So how will you call? Okay, let's look at. Now we have learned about lambda function, right? By using the lambda function also you can pass it. Yeah. So given y equal to sin y plus cos y, it can be written plus sin y cos y. Yeah, this is the expression, but write it as a lambda function, right? So now you can call with your initial guess. So this is the way we can call the defined method. Okay. So in the first case we have called with a predefined function, and in the second case I am passing a lambda function. Okay. So now let's move on to the next problem, finding the square root of a number. So far we have learned about how to find the fixed points and how to write a program for that and how to call it. Okay, let's move on to the next problem, how to find the square root of a number. Okay, so I'm expecting you to solve this and write a procedure. Y equal to square root of x. So how will you write in the earlier fashion? So in the fixed points we have some approach, right? Same approach we can use it for this problem as well. So what we are doing is here I just square both sides. So y square equal to x, and then y equal to what? Y square equal to x. So y equal to x by y. Yeah, right? So I am squaring it. Y square equal to x and y equal to x by y, right? So now in the earlier case what I have, f of x is nothing but x. So I have a fixed point and I have my solution. Now to find out a square root of a number, how to use that fixed point method of the we have calculated fixed point, right? That particular methodology, how to apply for solving this problem. Okay, so now let's look at my equation is y equal to x by y. Okay, so we will have to start with the initial guess and finally we will conclude something, right? So same thing we will follow here. Take an initial guess of y1. Okay, so I say that for example, it can be of 1 or 2 or 0.5 or whatever. Okay, and substitute this. Now the function is what? F of y is nothing but x by y, right? That's what we got it, right? So given y equal to root of x, and we got f of x, f of y is nothing but x by y. So your function is f of y is nothing but x by y. So have an initial value y1 and substitute here, so that x by y1 you will get y2. So y2 will be the next guess. All right. So you just substitute here x divided by y2, right? So now what is y2 here? Y2 is nothing but x by y1. You substitute x divided by y1. Yeah. For y2, I am substituting x by y1. So x cancel, you will get y1. So if you look at y3 is what? We are getting y1. Y2 is what? X by y1. Can you tell me what is the value of y3? So that y4, so that we can arrive to a common logic. What will be y4? Y4 is nothing but x by y3, right? Where y3 is nothing but y1. So substitute there. So what is y4? What y4? Students, are you there? Sleeping? What is y4? Y4 is nothing but
x by y3.
X by y3, where y3 is nothing but y1. So if you substitute, what you are getting?
y2.
Yeah, right. But that is your x by y1, right? Y4 will be x by y1. So if you repeat this one, and often I am getting the value guess, the guess is x by y1 or y1, then x by y1, y1. So this will be repeated, right? So my guess is actually our answer will be lying between y and x by y. That is my guess, right? Y and x by y. So in between, you will get some value, right? It is not nothing else. Actually, it is not 1 by y. It is not y square. Nothing else. Always I'm going to get y or x by y. So my value will be in this, right? So what I'm going to do is I'm going for a average of y and x, y, and from there I will compute the approximated value. Okay, so let me check how to do it. Okay, first of all, what I'm doing is average of y and x by y I'm taking. That is the initial guess. Okay, so if you look at this problem and how to write a procedure, let us look at what I'm going to find. I'm going to find the square root, defined square root, and for which I have to pass x, right? And fixed point of, okay, fixed point. I'm calling that earlier program what I have written fixed point of, okay. And what is the equation? My function is now, my function is average of y and x by y, right? Average of y and x by y. This is my function. And then call it with a guess value. I'm just starting with 1. Okay, so here finding the square root is going to use the previous function, that is finding the fixed points, we have already written. Okay, so converting the given problem to that type, okay, and then finding the solution. Okay, so now we have defining the square root for which we are calling the fixed point algorithm by passing the function. Now our function is average of y and x by y. And with the initial guess, I'm just going to iterate, and finally I will end up with some approximated value of square root of x. Okay, this procedure is called as average damping technique. This technique is called as average damping technique. So every time I'm going to calculate the average, and finally I will get a approximate value. Okay, right. So this is the one, and next we move on to how to write a procedure that will return procedure. Okay, we are going to write a procedure which will return a procedure. So far we were discussing writing a procedure that will accept a procedure as an argument. Yeah, you look at, there is average damp, and f is what? F is a procedure. So one of the argument is a procedure. But now we are going to write a procedure which will accept the procedure as an argument, as well as that function is going to return the procedure. Are you capturing the point? If you look at this, define average damp, f is a function, is an argument. If you look at the body and what it is returning a function, lambda function. Yeah, so this is accepting a procedure as an argument and returns a procedure as a value. Okay, this is possible in this language. It's a wonderful idea, right? Okay, let us look at. I'm just going to call this procedure by passing an function, average damp, and I'm passing square here. What will happen? Any guesses? What it will return? What it will return? See, this is going to return a function. Okay, I have defined a function, and I'm just calling with average damp and with a square. So what it will write? It will return to you. What it will return to you? In place of f, it will write square, right? Yes or no? Yes or no, students? You are just mesmerized, or you are just astonishing the language, the Lisp language. Oh, super. The concepts, writing the program, the power of the language? Are you appreciating or you're not able to understand anything? Students?
Yes, ma'am.
Priya
Can
is
you
the
just
one.
repeat the question? Like,
Yeah. The question is, if you are calling this function with this, what will happen? What is the output? What will happen?
we will be getting
Average
the
time.
average of square of x and
Yeah, see, what will happen is
not
it will
x.
substitute instead of f,
F
it will
of.
substitute square. Yes.
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Yeah. So lambda of x, average x, inside that f, f will be substituted with square. Right? Now, I'm just calling by passing the value. I'm just calling this by passing the value. You know how to call the function by using by passing the value, right? So here average dump of square, okay, and I'm closing it and then 10. What it will be? What will happen? So average dump square is going to return this. After returning, the 10 will be substituted for x, right? 10 will be substituted for x. So square 10, average of 10 and square of 10. Average of 10, square of 10. This is the body, right? 10 will be substituted in the body section, right? So x is what? It is 10 and f is what? It is square and x is what? It is 10. So now what I'm saying is in the Lisp language, right? If the function definition is returning a function, returning a procedure, what happens is the procedure is written, after that the value is substituted in the body. So if you have a statement like this, function and pass the function name, and then the argument is another function and substitute it. So for this particular inner bracket, this is the value to be written, and comma 10, what will happen? 10 will be substituted in the body for the variables, right? That's what we have learned so far. How to call a lambda function? What you will do? You will write a comma and then pass the value within a bracket. That's what we have done. Yeah. So the value what you will get is 10 and average of 10 and 100. You will get what? Okay. So you will get 55. Okay. So this is the power of the language. Your function is going to return another function. Your procedure is going to return another procedure. Okay. Okay, so this is what I told. Average damp of square, which will be returning the lambda function, and then the 10 will be substituted for the body. So average 10 square 10, so that you are getting the output like this. So in the earlier sessions, we know how to compute the expressions. What will happen? The inner bracket will be done first and then move on to the outer. So the inner is square 10, where square is another function, right? So it will execute the body of the square function. In that you have a into a. So this is coming and then evaluating and then evaluating. So innermost to the outside it is moving. Yeah. So now the average is another procedure. The body section is substituted. For the average, what is the code you have written? That is substituted. In this fashion, the Lisp interpreter is going to call the function or executing, evaluating the section, body or expressions. Is there any doubt, students?
Ma'am, it's the first line which we pass in the console, like how we call the function.
You call the function like this only. Average damp square 10.
10 is for that x value.
10 is for x value. Okay. Yeah. See, don't think that square 10. Square 10 means there's two arguments for the procedure, no? But we have only one argument. So that is why within a bracket we are writing this procedure is going to return another procedure and then the 10 is taken over. Right? Yeah. So now you just digest this idea so that we can go ahead for the next session. Okay. If you know the concept, then it is very easy to write the program and write the function, and calling the function will be easier. Okay. So it's nothing. What I told, the same thing. So consider in this particular example, average damp is the procedure name and passing the function lambda of y. Okay, what is that function? Y into y. Okay, in the earlier case, the function is different. This is the function to be substituted here. Okay, so what happens? I can call like this as well, right? So in the earlier thing, how I called? I have called with a square. Now I'm calling with a lambda function. Lambda function can take any number of arguments and it can have any logic in the body section. Yeah, here the logic is y square, y into y. Okay, so as it is substituted for f. Okay, so what will happen? What will happen? So you have a lambda of x, okay, and average x where f is nothing but this lambda. So this is substituted for f and x is here as it is we are writing. Okay, and then which one will be validated first? Which one will be validated first? Which one will be validated first? In the body section, in the earlier case, the body section is average x, lambda of y, in y into y, x 10. So what will happen? In the next step, what happens is we have to validate. So before validate, we have to substitute the value. So 10 is substituted for x. Right? Okay. Wherever the x is coming, the 10 will be substituted. So that is what is this step. And then this 10 is substituted for this lambda function, right? Where this 10 is relevant to y. Yes, so that instead of y, 10 is substituted. And we are getting the answer like this. Okay. Once you know the fundamental, same thing is applied. There is no change of concept. So while writing every procedure, we will call the procedure. While calling the procedure, the first case will be passing the built-in function. Another thing is writing your lambda function and passing it over. And then you may have some expression as well. For example, sin x plus cos y, like that multiple terms you can pass. So in all the cases, how the expression will evaluate. Okay, it's a substitution model. Okay, because actually, you know, so far we have our habit is we have read C language, C++, C Sharp, and Java. Okay, but now this is a little different. So that's why, you know, we cannot able to write fluently at once quickly. But after some days, you know, it will come. It will fluently you can able to write. But comparing to other languages, this is the thinking itself should be different. Yeah, how to solve the problem, the thinking, the logic itself little different than other languages. So in MIT, they used to teach this one in the first year. This is a very fundamental, very old language. And in many languages, the recent languages, they are using this concept. Okay. So I think by this chapter 1 is over. That is, in your syllabus, there are 3 divisions are there. One division is over. Let's move on to the next division in the next session. Any doubts in this? But every day you have to just look at the teaching material and also the exercises. And you also have answers for the exercises, and you can refer later. First you try and then later you can refer. Okay, so I hope that yesterday quiz given you, I think you learned a lesson, right? The subject is very simple. That concept is invalid. I think you have to put little effort to read this. Okay, and in the yesterday's answer, you don't know how to write a prefix itself for a given expression. You are not leaving the space. For example, plus AB, no space between plus and A. How come? And many they have written A by B, that is A divided by B. How come you can write like that? This shows that you don't know the language. So far, you wasted your time, right? All the expressions are to be written in the prefix notation. That is a very fundamental one, and that is the you don't know, then it's a problem, right? And in the prefix notation, you have to leave space, operator, space, and then operand, right? Plus space, and then operand 1, operand 2. Where is you're not putting the space. It is an error. Okay, I hope you have checked your AUMS valuation. What is the correct answer? What you have written? What is the score awarded? If any problem issues, you can ask me. Okay, so I think the message is posted already yesterday.
Then tomorrow's quiz, what all
Sorry, Lokesh.
Tomorrow's quiz, what are all the PPTs?
Tomorrow quiz.
Oh, sorry. Yes,
Tomorrow session. Tomorrow I will be taking class. Tutorial you are saying, no? Yeah, tomorrow
sorry,
I'll be taking.
I am really sorry. I thought family.
Your voice is breaking actually.
No, I was thinking of MLDM and I asked it.
I am not understanding, sorry. There are a lot of breaks. You can type in chat.
No, actually, I was thinking of other subject, thinking this as machine learning. I just asked.
Don't know.
By mistake, he asked me.
Okay, understood. Okay. Thank you so much, students. Have a great day. Bye, see you.